Okay, we're going to take a minute today to take a look at sequences and equations. These are fairly tricky. What we got going on here is we have a sequence, 2, 3, 4, 5. And what students are going to be asked to do is to describe the sequence. There's a couple different ways we describe a sequence when we get to this level of math, a pre-algebra, algebra type situation. Okay, we look at it in two different ways. One way is we look at what it's increasing by. Okay, in this case it is increasing by 1. But we also look at it in terms of term number and terms. Now the terms are the sequence itself. Term numbers are just the counting numbers, 1, 2, 3, 4. Okay, so we look at it in a relationship where we're looking horizontally at this. What's actually happening so we can write an equation. Okay, and in this case here, it's 1 more than a term number. Okay, so increasing by 1 more than a term number. Two different ways to kind of think about it. Mainly in elementary, you know, the students are asked to list the next 3 numbers in the sequence, which is fairly easy for most students. This is a little more complicated, obviously. So what we're doing here now is we want to come up with an equation, okay, and we start all our equations with, we want to find a term. Okay, so we start with t equals, and that's important because many students have a hard time getting started on these problems. So I tell them start them all the same, t equals. Okay, now you have a start point. Now what do we do to end to get t? And it has to work in every situation. Now looking at the sequence and what's happening to the sequence is the key to this. Okay, it's increasing by 1. So it's either going to be plus 1 or times 1. That's a starting point that you want to use. Okay, so let's say I added 1 to each one of these. If I add 1, I get 2. If I add 1, I get 3. If I add 1, I get 4. Okay, it's adding 1. So I got to organize this right. So I'm going to go n plus 1. Okay, so that would be the equation for this particular sequence. Now you might ask, well, why would you want to do that? Well, quite often they'll ask a question like, what's the 100th term? Well, you don't want to have to make a list to find the 100th term. Once you have the equation, you can just substitute 100 in for n, okay, and 100 plus 1 is 101. So the 100th term would be 101. You know, and we can check these. We put 1 in here, we get 2 for t. We put 2 in here, we get 3. We put 3 in here, we get 4, and so on and so forth. So that's how that one works. That's a relatively fairly easy one to start with. We do get some that end up being 2 steps. This is what I would call a 1-step. We're just adding 1 to it. Some of them we're going to be multiplying and adding, or multiplying and subtracting. So we'll take a look at one like that next. Okay, here's another one. Now this happens to be number 8 out of the textbook, and once again they're asking in this question to find the equation, okay, in the 14th term. So what I did is I made a little table here. Okay, remember once again, term numbers, that's n. Those are the counting numbers, 1, 2, 3, 4. So those aren't something that the book is going to give. Those are numbers that students have to come up with. They're just the order of the number in the sequence. This is the first number in the sequence. This is the second number in the sequence. This is the third number, fourth number. Okay, and once again now let's take a look at what's happening here. If we had to describe this sequence, okay, it's increasing by 4. Okay, that's what the sequence would be as far as description goes. But when we look this way, okay, something else is happening. It's not just being increased by 4, right? So we're going to use that increasing by 4 to help us to find the equation. So once again, we start this t equals, just like the last one. Remember that starting point, kind of a tough spot. So start them all the same, t equals. All right, now let's go back to the description of the sequence. It's increasing by 4. Okay, so that 4 is going to come into play here. Either add 4, multiply by 4. So if I start with adding 4, if I multiply, or if I add 4, if I add 4 to 1, I get 5. Add 4 to 2, I get 6. Well, it works for that one. I add 4 to 3, I get 7. That doesn't seem to be helping me much. Okay, well, let me try to multiply by 4. So if I multiply by 4, okay, I get 4. Well, that's 2 too many, so if I multiply by 4 and I subtract, let me try multiplying by 4 and subtracting 2. Because 4 times 1 is 4, minus 2 is 2. Okay, 4 times 2 is 8, minus 2 is 6. I might be onto something. 4 times 3 is 12, minus 2 is 10. 4 times 2 is, or 4 times 4 is 16, minus 2 is 14. I got it. Okay, so what I have to do here is I have to multiply by 4. Okay, so it's going to be t equals n times 4, so 4n, but I also have to subtract 2 from it. This is one of the two-step ones. These are the most difficult ones. Now you might be, well, how did you ever get that? Well, you get it by looking at what this sequence is increasing by. It's increasing by 4. So that right there is the hint. You know you're going to either probably have to multiply by 4 or add 4, and then you got to kind of play around with it a little bit. Okay, multiplying by 4, then I had to subtract 2. On some other ones, you're going to have to maybe multiply by 4 and add 2 instead of subtract 2. But the key is looking at what the sequence is increasing by. That will give you the hint to find this. So now if we're finding the 14th term, now we would put 14 in here, so we would have 4 times 14, okay, minus 2. Okay, and 4 times 14 is, what, 56? Okay, minus 2 is 54, if I did that correctly. So that's the way that works. These are fairly challenging problems. They require students to work at them. However, I think they're gettable with effort. Hope this helps.